Well, now we have defined the complex number system, but these are supposed to be numbers, and so we should be able to do some basic operations like add, subtract, multiply, and divide, and even powers and roots with these numbers. So let's see how we would define some of these operations. So let's start with addition and subtraction. So, well, it just works like you would think they would work, and basically you can treat a number a plus bi basically kind of like it was a plus b times x and do it like it was a polynomial, except that you got to remember that I squared equals -1, so some things kind of collapse a little bit. So you can say a plus bi plus c plus di. A plus bi is actually the real number a plus the imaginary number bi. And so you can break this down into four numbers, a, bi, c, and di, add them up by using the commutative and associative properties, and what it boils down to is you can just add up the a and the c, and then the b and the di, you factor out the I, and add the b and the d. So we define, ultimately, we define complex addition a plus bi plus c plus di to be a plus c plus b plus di. So in other words, just add them like you think you would add them. You just add the real parts to get the real part of the answer, and you add the imaginary parts to get the imaginary part of the sum. And similarly, with subtraction, we essentially just distribute the negative and combine like terms. So we have a plus bi minus c plus di is a plus bi minus c minus di. So that's a minus c plus b minus di. So let's look at a couple of examples over here. So here we have, with the same a and b and the c and d that we can control by here, we can see those points here worked out, which we have them graphed. Okay, so here's our point w and our point z. Our point z is -1, 3, or square root of 10 times e to the I times -1.89. And w is the point -2 plus 1i, or square root of 5 times e to the I times 2.67795. So where would be z plus w? Well, we just add the x components. So we're adding the 1 and the -1 and -2 to get -3. And we're adding the -3 and the 1 to get -2. So it's -3, -2, there it is. It's a red, there's the red point there. And of course, if you're thinking about it, it's really just the same thing as adding vectors. So if we add the position vector here, say we start with going out the vector w, then if we come back the vector z here, then we get that vector. We end up with the point here, z plus w, which is like getting the position vector from the origin to there. So really, it's a lot like adding vectors. Just add the components. Pretty, pretty easy breezy. Okay, so similarly, if we want to do z minus w, we go here, and then from w we go in the opposite direction of the position vector for z, and we get up here. Or in other words, if we just subtract their components. So it's -1 minus a -2, which is -1 plus 2, which is -1 for the real component, and the imaginary part is -3 minus +1, which is -4. So we end up with 1 minus 4i, which I don't seem to have graphed in the right place. So let's see if I can get rid of that here and put this in the right place. So it should be 1 minus 4i okay. It should be down here. So we go in the direction z, and then we go. So let me do it. A couple ways I could do it. One thing I do is I could just say graph the point and we want to go here, here, and plot that. Oh, that's the one I already have. And I want to plot this one, and that should be the correct value for the point that I'm looking for. So this vector here is the green vector. Okay, which is from W, the opposite of W. So going from W back to the origin, that's the same as go to Z first, and then from there go that far over here. So this one actually right here is Z minus W. Okay, so basically you can see that you can visually see it. So this one up here is not right. Let's get rid of that. And so you can see where we end up. Okay, and we can see that little parallelogram there. You do it this way. So you first go in the direction Z, then in the direction W, with the same as the vector there, and then it's like going the vector here and here. So you can see visually the vector addition there, but you can also see it, of course, just as components there. So just like adding vectors, it's much easier to add vectors in component form. So you'll want to, if you start with them in polar form, then you're going to want to probably go ahead and just convert them to component form and add them together, and then convert back if you need to. So that is complex addition and subtraction. It's not really complex at all. Just add the real parts and add the imaginary parts.